Good morning, student. My name is Dr. Tanmay Das. Today we are going to discuss a very interesting topic on photoelectric effect. That is why intensity does not matter in photoelectric effect. Okay. So now to understand this one, let's go to our whiteboard. Okay. So now I think you all can see the whiteboard. So here you see, for example, just to understand the situation, let us imagine you are shining a very bright torch light on a material block or a metal block, then you see nothing happens. But if you just change this light, torch light, with a very dim, maybe not much of intensity, very dim color, dim blue light or ultraviolet light, like this, then you see the electrons start to come out of the material or the surface. Okay, so here in this case, we are using a very low intensity light, and in this case, we are using a very bright light. But here, the observation is quite different or quite unexpected. In this case, we see the emission of electron, but in this case, we do not see any emission of electron. Okay, isn't it quite unexpected? Because in our day-to-day life, what we see, like in our classical world that we see in our surrounding, we see more is the intensity, more is the energy. Okay, so just for example, if you consider a condition, for example, you are shining a laser light on a metal. If you just use a very low intensity laser light, then what happens? The laser light will just hit the surface of the material. If you increase the intensity, the rate of hitting will also increase. Like if you use a very high intensity laser light, then it will transfer more and more amount of energy with a very short time. Okay, so material will heat up gradually. So the material is getting heat up means what is happening? Our heat energy is getting transferred to the material continuously by thermal radiation. You will know the thermal radiation means in the form of electromagnetic radiation or electromagnetic wave. Okay, so here the material will heat up continuously. That means energy transfer is happening continuously. So this is what also we can expect in case of electron. In case of light, when light is interacting with electron, then what happen in a material? For example, if we consider a material, electrons are generally bound to the material, like bound to the nucleus. So they will not spontaneously come out of the material. But if we provide them the sufficient energy, then only they will come out of the surface. That energy we call it as a work function, or we can call it as a binding energy. So if you provide that much amount of energy, then they will come out. So in this scenario, what we can expect? We can expect that we are shining a laser light. Okay, so it has sufficient very high intensity, so we can continuously provide energy. And if when the energy reach the minimum amount of energy required to remove that electron, then electron should come out of the material. Okay, so this is what we have understanding from the classical world, and this is what we expect in this case, right? But interestingly, if you repeat this experiment for multiple wavelength of light, for example, here we have red color light, then we have orange color, and then blue color. In all these three different color of light, we see the result is quite different. And if you see, we are shining with a very high intensity red color light, then we gradually decrease the intensity. If we go look at the blue color light, we see a very faint and a low intensity light. But here you see, even if we shine a very high intense red color light, we do not see any electron. But even if we use a very faint UV light or blue color light, the electron will come out of the surface instantaneously. Okay, so this is we observe. This is our observation, and this is our understanding as of now. Okay, so this was quite problematic. Like we cannot understand why this is happening like this. It is counterintuitive, right? So this was a very big puzzle during that time, and eventually here we see that the photon energy is directly related to frequency and does not depend on intensity. So it was not at that state we not able to understand. But with time, actually, it was first explained by Albert Einstein, and for this he actually awarded his Nobel Prize because he come up with a very mind-bending idea that our photon or the light. Okay, so generally before that, we used to understand the different phenomena of light like interference, diffraction. In all those cases, we used to consider that light as a electromagnetic wave and it will continuously transfer energy. So here he gave a really interesting idea that light is not always behave like a wave. It has a dual nature. In some situation, it can behave like a wave, and in some situation, it can behave like a particle. Okay, like you have different kind of behavior. We have also sometime when you are in your home, you behave differently. When you are in your hostel, you behave differently. Okay, now you understand. You are the same person, but your behavior is quite different when you are at home and when you are at hostel. That means depending on the situation, your behavior may be different. So similar is the case for light. So when light is interacting with the bulk, or in that case, we see the light show a wave-like characteristics, like it behaves like an electromagnetic wave, and it will continuously transfer energy to the material. So if you shine the laser light, it will continuously hit the material. Okay, but here we consider that light it is not like a wave. When we are when the light is getting interacting with the electron, it behaves quite different. When it is interacting with the bulk, it behaves like a wave. When it is interacting with the electron, or it is interacting at the electronic level, the behavior is quite different. It behaves like a particle, and this particle we'll call it as a photons. Okay, so now just to understand this one, you can just remember your childhood. Okay, so here you might have played this game. So here what we did, we just strike a marble with another marble, and if the energy is sufficient, then that second marble will get ejected from the surface. Now just for a better understanding, let us imagine that the marble is getting we just stick some glue, or we use some glue on the marble and we stick with the surface, and now the marble stick to the surface, and the glue has some binding energy, and if you provide the energy greater than the binding energy of the glue, then only the marble will come out of the surface. Okay, so now just imagine uh, initially we just this person came, this person just throw the marble with a very low energy. That means the energy is less than the binding energy. So here this one has some binding energy, so it is get stuck here because of the glue. And if the energy with which he is striking, maybe the energy is low with which it is striking, then in that case this one will not come out, this one will not come out of the surface. Okay, even if like 500 people came, because in case of particle, more is the intensity means more is the number of particles. So if like 500 people came, they just keep on throwing one after another, then if the energy is not sufficient, then the marble will not come out of the surface because it is bounded with a glue. Okay, but even if a single person just came, okay, if the single guy come and he strike with a sufficient energy, if the energy is sufficient, here in this case the energy is sufficient, or the energy with which he is striking, or the binding energy, it is greater. That means here we consider the energy is greater than the binding energy, or here in this case we actually call it as a work function, and we denoted it with phi. So if energy is greater than phi, then in that case what happen? In that case, our electron will come out. Okay, so now we can understand, if we consider the light as a particle, then in that case we can explain the behavior. But if we consider the as a wave, then we cannot explain. So here in this case, the energy will get transferred from one particle to another. Like each particle will transfer energy. They cannot continuously transfer energy. They transfer energy discretely. Okay, so this is what actually we observe. Only the photons with energy greater than the work function can eject electron. And if the intensity is more, that means we have more number of photons, but more number of particle. But it does not mean that more energy per photon, because both are different thing. One is more energy per photon, and another is intensity. That means more number of photons. So here we understand that more number of photons is not going to strike out this marble, or more number of striker will not going to strike out this one. But if even if the single person came with sufficient energy, or more energy or sufficient energy per photon, then in that case our electron will come. Okay, so now if we conclude, here what we understand, now we understand that intensity is not equal to energy per photon. If we increase the intensity, that means we are just increasing the number of particle. It does not related to the energy. Okay, then second thing, we understand that only frequency matter. Intensity doesn't matter in photoelectric effect, but only frequency matter. If we increase the frequency, that means we are increasing the energy. And if it is more energy, then in that case only our electron can come out. And definitely our classical idea that we have before, it fails, and the new idea that the particle has a dual nature or the radiation has a dual nature, so that actually win, that is our lead to a new physics, that is quantum mechanics, that we will discuss someday later. Okay, so now I think you all understand that why intensity, even if we use a light of very high intensity, it cannot emit our electron from the surface. But if we use a light of very low intensity, but it has very high frequency or the sufficient energy, then it can eject the electron. So thank you so much, and wish you all the best.